The eagle has landed. Welcome to Maths. This is Mangeya, the Maths Eagle. Right. So this part is for Cambridge International Advanced Level Pure Mathematics Paper 3 for May-June 2021, Variant 2. Then after watching this video, please like, share, and subscribe to this nice, powerful item. Let's start the ball rolling. Right. First thing first, instructions, especially on this part, based on the degree of accuracy. If it's not specified, please 3 significant figures or 1 decimal place for angles in degrees, not in radians, but in degrees. Question number 1. These are modulus functions, modulus inequalities, right? So what you have to do in this case is you just have to square everything. So is to get rid of the modulus function. On this left side of our inequality sign, we have 2x minus 1. You square 2x minus 1. On the right side, we have 3. You square 3. And also you have x plus 1. You square this item. Then you expand, collect like terms. Then you find the critical values. Then you can find your solutions. So let's expand. These are double brackets. You can say 2x minus 1. Then 2x minus 1 less than 9. Then this bracket is x plus 1. Then x plus 1. Double brackets. Right. The values in the first brackets multiply the second bracket. Like on this side, we have 2x and we have minus 1. So 2x multiplies the second bracket, 2x minus 1. Minus 1 multiplies the second bracket also, which is 2x minus 1. Then less than, you maintain your 9. You remove this bracket. It will be x multiply the second bracket, x plus 1. Then plus 1 multiply the second bracket of x plus 1. Then you put a big bracket. That is to make sure 9 is outside these items. Right. Then let's multiply 2x times 2x is 4x squared. 2x times minus 1 minus 2x minus 2x. Then 1 times 1 is plus 1. Less than. Then you maintain your 9. You say x times x, x squared. Then plus x plus 1. After that, you can simplify a bit. You can say 4x squared minus 4x plus 1. Less than. Maintain your 9. Then it will be x squared plus 2x plus 1. And that's what will be inside the bracket. Then let's remove the bracket with 9. Multiply by 9 on the right side of our inequality sign. Plus 1 less than. 9 times x squared is 9x squared plus 18x plus 9. Like this. Now collect like terms. It will be, let's take everything to the left side, right side of the inequality sign. So it will be 0 less than. Then 9x squared minus 4x squared. Collecting like terms. Then plus 18x minus, it will be plus 4x. Then plus 9 minus 1. Then 0 less than. Then this part you get 5x squared. Then this part you get 22x. This part you get plus 8. This is the same as 5x squared plus 22x plus 8. Then is greater than 0. Like this. Right. We have to find the critical values of x. You can use completing the square method, the quadratic formula, or factorization if it can work. But I can prefer to use the quadratic formula. So using the quadratic to find critical values of x. I can say my a is equals to 5, b is equals to 22, then c is equals to 8. Like this. Then using the quadratic formula, I can say x is equals to minus b. It says x is equals to minus b plus or minus the square root of b squared minus 4ac or over 2a. So that's the quadratic formula. Now b is 22. So it's minus 22 plus or minus root of 22 squared minus 4a. That's 5. Then c, that's 8. Or over 2 times a, which is 2 times 5. Then from this, you get x is equals to, if you can use your calculator, let me punch everything. Quadratic. Right, the first solution, you get x is equals to negative 2 over 5, or x is equals to minus 4. Minus 4. So these are called the critical values of x, right? A critical values of x. The smaller one is negative 4, and the bigger item is minus 2.5, 2 over 5. Now what you have to do to find the solution, you draw your line, then your quadratic graph. And the coefficient of x squared on our quadratic item is positive. So my graph will be like this. Right? Then you put the smaller value, it's negative 4, and the bigger one, negative 2 over 5. Negative 2 over 5, that's the same as negative 0.4. It's still the same as negative 0.4. Right? Then check the inequality sign. This one is greater than, which means we want the portion or the part that is above this line. This line. So above this line, that's greater than. Then below this line, that's less than. So and above the line. So the area bounded by the line and the curve. So we have this part. You have this part, and also this part. So these two parts, they form our solution set. So my solution will be x less than negative 4. Union, you can use U, or you can just say O. X greater than minus 2 over 5. Then this will be your solution set. Done. Right, next question, number 2. On a sketch of an Argand diagram, shade the region whose points represent the complex number z, satisfying the inequalities. We have this first part, z, then 1 minus I, less than or equal to 1. Then we have the Argand or argument of z minus 1 is less than or equal to 3 over 4 pi. Right, start simplifying with this first part. It will be z, it's supposed always to be in this form. It's supposed to be z minus, then x plus yi. Then is equals to h. So this one will represent a circle with center. So a circle with center xy. And radius, which is my r, a. Then based on the argument of z is supposed to be z minus x plus yi. Then so this is the formula, less than, or let me just say equals to theta. So this one represents a line having one point or one end at point xy and making an angle of theta with the positive x-axis. So that's how you interpret the arguments of a complex number. Right. Then I can simplify this part. So it will be minus, always factor out minus here. Then it will be the real part is 1. Then plus I. Then less than or equal to 1. So this one will represent a circle. Circle, center, 1, 1. Then radius, 1. Then for the argument, it will be argument of z minus, then real, then plus 0i. Less than or equal to 3 over 4 pi. So this one represents a line having one end at 8.10 and making an angle of 3 over 4 pi. Right? 3 over 4 pi in radians, then you can convert the same to degrees if you can see yourself getting confused with the radians, right? It's easier working with the radians with degrees than working with radians, but still it's the same thing. You still get the same answer. So if you can say 3 pi over 4 is the same as 0.75 times of 180, so the same as 135 degrees, right? So the same as 135 degrees when it comes to degrees from radians to degrees. Right, now we have to have our sketch. So if I can draw my sketch here, let me put it somewhere. So this is my sketch. This side represents the imaginary y, and this side represents real x. Right. Then we start with the first part. So the first part represents a circle, center 1, 1. So if I can draw here, 1. Actually, this one, for the real, it's -1, so that it will be plus. If you can say minus, minus, then it's supposed to be plus. So this one is supposed to be minus here, not plus, right? So that you can remove this bracket, then you must get back to your original item, which is this one. So it's -1. So I can say 1, then 2 here, then 3, -1, -2, -3. Then on the y, I can say 1, then 2, then 3, -y, -1, then just end at -2 like this. Right, so the first part is a circle, center -1, 1, -1, then 1 is there, is somewhere, making an angle, having radius of 1. Radius of 1, so it means, let me use different ink here. So it means down here, supposed to end at 1, somewhere supposed to be 2. Up there, it's supposed to be somewhere ending at 2, then here at 1. So these are like this, like this, like this. So this one is my circle. Then less than or equal to 1. Let me first draw the other one based on this one. On the argument. So on the argument, it's a half line. It's a line having one end at 1, 0, and making an angle of 135 or 3/4 pi with a positive x-axis. So x1, y0 is this part. Is this part. Then making an angle of 135. So it's supposed to be like this. Like this. Let me draw a proper one. Right, so this one is the line. Let me draw a proper one. Right, so this one is my line. Then this angle is the one that is supposed to be 3/4 pi. Or 135 degrees, right? Then the area in between these two items, the area, if I can shade, is this part. Like this. So that's the area. That's the area. So that will be my graph, right? So that's the Argand diagram representing these complex numbers. Right, question number 3. The variables x and y satisfy the equation. This one, where a is a constant. Explain part A. Explain why the graph of y against ln x is a straight line. Instead, the exact value of the gradient of the line. Straight line in this case. So what you just have to do from your equation, you have to find ln x. You have to find y. So you have to make y subject and express in the form y is equals mx plus c, where m is the gradient and c is the y-intercept. So this part, I can introduce ln both sides. So I can say ln x is equals to ln a, then 3 to the power -5. After that, I can apply the laws of logarithms. It will be ln x is equals to ln a plus ln 3 to the power minus y. Right? Ln A plus ln B is equals to ln AB. Ln A times B. So that's the law on multiplication. So you add. In this case, it's multiplication. A times 3 to the power negative y. So you just add. Then it's ln x is equals to ln A minus y ln 3. Remember, we want to find y and we want to find, or we must have ln x. So you can take y ln 3 to this side, then x on the other side, minus ln x, then plus ln A. So we're trying to express in the form y is equal to mx plus c. Now you divide by ln 3, everything by ln 3. Ln 3. Then by ln 3. Such that this side, it will cancel out. So you get y is equal to minus 1 over ln 3, then ln x. Like this. Then plus ln A over ln 3. Now we have our equation of the form of y is equal to mx plus c. Now our gradient, that's m. You can say y is equal to mx plus c. So from this, you can say that x, that represents ln x, then c is represented by ln A over ln 2, over ln 3. Then y is the same as y in this case. So m is the gradient, that is, m is equals minus 1 over ln 3, like this. Are we supposed to leave as an exact value? Then they said instead the exact value of the gradient. So this one will be the exact value for our gradient, minus 1 over ln 3, done. Right, next part. It is given that the line intersects the y-axis at the point where y is equals to 1.3. Intersecting the y-axis, the vertical, you can know that x is equals 0. So the point will be 0 and 1.3. x 0, y 1.3. Then they said calculate the value of a, giving your answer correct to 2 decimal places. It is given that the line intersects the y-axis. So which line now? With a gradient minus 1 over ln 3. So it intersects the y-axis at the point 0, 1.3. Right? Take note of that part. Right, so our graph is y against ln x. It's more like y against ln x. So if it's intersecting the y-axis, then it means the value of ln x is equal to 0. So this one is the value of ln x. And this will be the value for y. So we can substitute in our equation. So I want to find the value of a. Right, giving your answer correct to 2 decimal places. So we can just substitute in our equation. Or we can just right, there are two things. There are two things. So it's either you can substitute where there's ln x, you put where there's ln x, you put 0. Where there's y, you put 1 over 1.3. Then you can find the value of ln a, or a actually in this case, want a, right? Or ln a over ln 3. It represents the c, which is the point where the graph intersects the y-axis. So you can just use that one. It's actually easier and simpler. You can just say y-intercept that c. C is equals to ln a over ln 3. So the point or the y-intercept, it will be 1.3. 1.3 is equals to ln a over ln 3. Then cross multiplication, you get ln 3, then 1.3 is equals to ln a. Right? Then you can raise the power e, or you can apply the laws of logarithms. You can say in this case, ln 3 to the power 1 of 1.3 is equals to ln a. Then if it's like this, ln, then it means a is equal to 3 to the power 1.3. It will make sense this way. Or you can raise both sides to the power e, so as to get rid of ln. Because ln e to the power n number, ln e to the power n number, x is equal to x. Or e to the power ln x is still equal to x. That's the concept that you can apply. So our a, you can say 3 to the power 1.3. You get 4 points. So our a, how many decimal? 2. 4.17. Like this. Then done. Right, question number 4. Using integration by parts, find the exact value of the this function. Right, we are integrating arctan half x. Arctan half x, we have actually on this part, if we are integrating, this one can't be integrated, it can only be differentiated. So it's differentiation of tan arctan x is 1 over 1 plus x squared times the first derivative of x, right? Times the first derivative of x. So that's how you differentiate arctan x. Is there in a formula booklet? Formula booklet. Right, so is this one. Arctan, so is this part. Arctan of x, derivative is actually 1 over 1 plus x squared. That's the derivative. Right, so since we know that arctan can only be differentiated, so we have to integration by parts. Is this part is v du over dx, then dx, then is equals to uv minus the integral of v du over dx, then dx, like this. Right, so we have to let our u is equal, our v actually, the first one is u dv dx, so it's u dv dx, u dv dx, so it's v du dx. Yes, so it will be, let our u is equals to arctan x, that is arctan half x in this case, then our dv over dx then is equals to 1. You can let it be 1, so you can put 1 is somewhere here multiplying this part. Right, then differentiate, we say du over dx, it will be what? Right, arctan half x, it will be 1 over, then you say it's 1 over, then it will be 1 plus half x, then squared, that is 1 plus x squared, so it's 1 over 1 plus x squared, then times the derivative, right? The derivative here. Right, so you say here, so it will be times the derivative, it will be half. Actually, it's down here. Times half down here, like this. Then it will be 1 over, then 1 plus, can put inside the brackets, then it will be 1 x squared over 4. Then times 2. Like this. Let me simplify it further. So that I'll get 1 over, then multiply by 2, you get 2 plus, then this part, you get x squared over 2. Right? Then express this one, you put under one denominator, it will be 1 over, then denominator, this one will be over 1. You get 1 into 2, 2, 2 times 2 is 4 plus x squared, like this. Then you can divide, you get 1, actually it will be 2 over 4 plus x squared. So this will be the derivative of arctan half x. Now on this side, to find our v, we say first thing, separate variables, 1 dx, then integrate both sides, you get v is equals to x, like this. Right, now the integral of this function, it will be integral of arctan half x dx is equals to, then you say uv. What is our u? U is arctan half x, then our v is x, so it will be x arctan half x minus integral of what? Of v, that is x, times du over dx, which is 2 over 4 plus x squared, then dx, like this. Right, next, I can simplify inside this bracket, under this, inside the integral sign, it will be x, then arctan of half x, minus, let me simplify it first, then it will be 2x over 4 plus x squared, then dx, like this. Right, I can use integration by inspection, since you can check The numerator is the exact derivative of our denominator. So you can just use ln. So it will be x arctan half x minus, then this will be ln 4 plus x squared. Then do we have plus a constant or do we have limits? Let me check. We have limits 2 and 0. So we have to put our limits. So it's 2 and 0. Right now we have to put our x2 and our x0. Then do you have to find it as exact? Yes, find the exact value of, not as a decimal number. Right, put x2, it will be 2 arctan of a half times 2 minus ln 4 plus 2 squared, like this. Then subtract, put x0, it will be 0 times arctan of half times 0, then minus ln 4 plus 0 squared, like this. Then let's simplify. Let's simplify this part. So arctan, make sure your calculator is in radian mode actually. What's arctan of 1? What is arctan of 1 in radian mode? Radian 4. So arctan 1, arctan of 1 is pi over 4. So it will be 2 times pi over 4 minus, on this part, 2 squared is 4 plus 4 is 8 minus ln 8. Right, this part, then minus 0 times this one. This whole thing will be cleared to 0. So it will be minus ln 4, like this. Right, then you can simplify to pi over 2 minus ln 8, then plus ln 4. Simplify further, you get pi over 2, then ln 8 minus this one, it will be minus, right, you can apply the law on, you can say plus ln 4 minus ln 8. Start with the one that is positive, then plus this one, then plus ln 4 minus ln 8. It's actually ln 4 over 8, like this. That is ln half. If you can simplify, it will be pi over 2 plus ln 1 over 2. Then ln 1 over 2 is the same as ln 2 to the power negative 1. Applying the laws of logarithms, pi over 2, then plus ln 2 to the power minus 1. Then I can bring down the negative. It will be pi over 2 minus ln 2. So this will be the exact value of this integration. Done. Question number 5. The complex number u is given by u is equals to 10 minus 4 root of 6i. Find the two square roots of u, giving your answer in the form a plus ib, where a and b are real and exact values. Right, these are 5 marks. Square roots of a complex number, we can represent them by z. So you can say the square root of this item, you can say z squared, that's the square root, or z representing the square root of this function. You can say our z is equals to the square root of 10 minus 4 root 6i. Then it will be z squared is equals to 10 minus 4 root 6i. Then our complex number z is represented by x plus yi, or x plus iy, whichever way. So you can replace now or substitute x plus yi, then squared is 10 minus 4 root 6i. Right, let's expand the left side of our equal sign. If you can expand this part, you get x times x, x squared. You get x times yi, it will be xyi. Then x plus yi is xyi. Then plus, then yi times yi is y squared, I squared. Then is equals to 10 minus 4 root 6i. Then if you can simplify, use I squared is equals to negative 1. Right, so this bracket is just one bracket, two brackets of the same item. So how did I expand it? is x plus yi, then x plus yi. So that's the bracket. So I have expanded this part to be this item. Take note of that part, please. Right, then it will be x squared plus 2xyi. Then I squared minus 1, it will be minus y squared. Both I squared minus 1, y squared times minus 1, you get minus y squared. Then it equals 10 minus 4 root 6i. Right, now what you have to do, you have to equate the real to real, imaginary to imaginary. But let me collect the real first. It's x squared minus y squared, then plus 2xyi is equals to 10 minus 4 root 6i. So the real on this left side, we have x squared minus y squared. Must be equal to the real on the right side of our equal sign, which is 10. Then the imaginary, which is 2xy, must be the same as the imaginary on the right side of our equal sign, which is negative 4 root 6. Right. These are now two equations. Equation 1, I can call this equation 2. These are two simultaneous equations. I can solve them simultaneously. Right. Let me make x or y on the second subject of formula in the second equation, equation number 2. I can prefer to make x in this case. Right. So if I can make x, I can say, or let me just make y. I can say y is equals to, then minus 4 root 6 over 2x, which is equal, so my y will be equal to, for the sake of my space, but still okay, y is equals to, so I can say y is equals to, then minus 4 root 6 over 2x. So my y will be equal to 2 into 4 is minus 2 root 6 over x, like this. Then I can take this, I can substitute or make this my equation number 3. Then I can take this, then substitute in equation 1. So substitute in equation 1, then I'll get x squared. Where there's y, I will put minus 2 root 6 over x, then squared is equals to 10. I have to solve this one now, right? It will be x squared minus, then this part, it will be 2 squared negative, we cancel out, then 2 squared is 4, 4 times 6, it will be 4 times, root 6 times root 6 is 6 over x squared, then is equals to 10. Then simplify further, x squared minus 24 over x squared, then is equals to 10, right? Then get rid of our denominator, which is x squared in this case. Multiply everything by x squared. It will be x to the power 4 minus 24, like this, then is equals to 10x squared. Then collect this, everything to the left side of our inequality of our equal sign. It will be x to the power 4 minus 10x squared, then minus 24, then is equals 0. Then you can factorize this part. Factorize this part, it will be x squared here. Then let's just put x squared, then x squared here. Let me factorize this part. Right, what are the numbers? When you multiply them, they give you negative 24. When you add or subtract, they give you negative 10. The numbers are, is it minus 12? It's minus 12 and plus 2. Minus 12 and plus 2. These are the numbers, right? If you can multiply them, add or subtract, negative 10. So it will be, it's either x squared minus 12 is equal to 0, or x squared plus 2 is equal to 0. Then it will be x squared is equal to 12. From this you get x is equal to plus or minus root of 12. Then from this you get x squared is equal to negative 2. Then square root of a negative number, that will actually be complex, right? So you don't take this part. So for this part you say no solution, right? No solution. Why? Because it's imaginary. It will give you square root of negative 2. So now you can simplify this part. So it will be x is equal to, root of 12 can be simplified to plus or minus, because it's root of 4 times 3, or root of 4 times root of 3. So it will be plus or minus 2 root 3. So this will be my x. What about my y? For y, you have to substitute in equation 3 here. So if x, when x is equals to minus 2 root 3, what will be y? Y will be equal to minus 2 root 6 over minus 2 root 3. Then 2 cancel out. Then if you can find your calculator, you can make use of a calculator. Root 6 divided by root 3. You can say root 6 divided by root 3 divided by root 3, you get root 2. Right, so it means the same thing will apply when x is equals to 2 root 3. The only difference will be the sign, right? So the sign, it will be y is equals to minus 2 root 6 over 2 root 3. So it will still be root 3 root, but negative now. Why? Because the negative will not cancel out. So you can find your roots now. You can say, what the square root? The first one, you can say our root, it will be x is minus 2 root 3. Then plus y will be I root 2. Like this. Then if x is 2 root 3, then our y will be negative I root 2. So this will be the 2 square root of this function. Done. Next, question number 6. Prove that cosec 2 theta minus cot 2 theta is identical to tan theta. Right, we want to find tan. So tan is sine over cos. Sine theta over cos theta. That's tan. So we must make sure that our numerator must be reduced to sine and our denominator must be reduced to cos, so that we can have tan. Right, I can take the side, the left hand side. So you can say taking left hand side because there are a bit more items on the left side than on the right side. So I can choose the left. Cosec is 1 over cos. 1 over sine. So it's 1 over sine 2 theta. That's cosec. There is there in a formula booklet. Then cot. Cot is cos over sine. Cos 2 theta over sine 2 theta. That's cot. Then put everything under one denominator. If you can check, denominators, they are the same. So you can just say sine 2 theta. Then it will be 1 minus cos 2 theta. Like this. Right. Let me simplify. The numerator, they must be sine. Denominator, they must be cos. So you can use the identities. They are there in a formula booklet. For cos in terms of sine. And for cos 2 theta in terms of sine. And cos 2 theta in terms of cos. So cos 2 theta is 1 minus 2 sine square theta. Or cos 2 theta in terms of sine. In terms of cos is 2 cos square theta minus 1. So these are the two identities that I have to apply in this case. So for cos 2 theta, I can say 1 minus, then cos 2 theta. Since my numerator must be sine, I can use the one with sine. Minus 2 sine squared theta over my denominator must be cos. So it will be 2 cos. Actually, this one is sine 2 theta. So sine 2 theta is 2 sine theta cos theta. Is there in a formula booklet. So it's 2 cos theta sine theta or 2 sine theta cos theta. That's an identity for sine 2 theta. Right? Remove the bracket 1 minus 1 plus 2 sine squared theta over 2 cos theta sine theta. Like this. Then 1 minus 1, 0. It will be 2 sine squared theta over 2 cos theta sine theta. Then if you can simplify this item, sine squared, it means sine. So the sine will cancel sine. 2 will cancel out. So we'll be left with sine theta over cos theta. That will be tan theta. Done. Next, show that the integral of cosec 2 theta minus cot 2 theta d theta is half ln 2. By this part, what you have to do is you have to use tan, because we have indicated that it's identical to tan theta. So instead of using this item, you use tan theta a. Then d theta. Then you have pi over 3 and you have pi over 4. Like this. Alright? Then tan theta, can it be integrated? No, you can only differentiate tan theta, but not integrate it. So what can you do? You can use an identity, that is sine theta over cos theta. So it will be the same as sine theta over cos theta, then pi over 3, pi over 4, then d theta. Then you can use integration by inspection, where the numerator is the derivative of the denominator, right? So for it to be the exact derivative, differentiate cos theta, you get negative. So you have to make sure it's the exact. But for it to get back to sine, you have to factor out the negative sign. So that negative will cancel out. It will be sine. Right? Then you say ln. So it will be ln cos theta, like this. Then you put your limits, pi over 3, then pi over 4. So this one is the integration of derivative of f of x over f of x. So you just say ln f of x plus a constant. That's how you differentiate this part. Derivative is the numerator of the denominator. Then just ln denominator plus a constant. Right? Then if you can now put the limits, it will be ln cos pi over 3 minus ln cos pi over 4. How much space? Oh, just a small item. 4 marks. Right, then you can make use of a calculator. Right, so from your calculator, ln pi over 3. What is pi? Cos pi over 3. First punch, cos pi over 3 in radians. Pi divided by 3, you get half. Minus ln pi over 4, you get root 2 over 2. Like this one. So that's cos pi over 4. Then let's simplify this part. Right, to simplify this part, you can say ln, apply the laws of logarithms. It will be 2 to the power minus 1 here. Then minus ln. Then this one is 2 to the power half over 2. Like this. Then you can say minus ln 2, applying the laws of logarithms. Then minus. Then this part, you maintain the base and you add the power. You subtract the powers. So half minus 1. Half minus 1 is what? It's minus half. Right? Bring down the half. It will be minus ln 2 minus half ln 2. It will be plus. Actually, this part will be clear to plus. Right? You have half ln 2 minus ln 2. Half ln 2. So it will be actually simplified to, what is our item? Our item, there's no negative number. There's no negative number. So I'm supposed to say half minus 1 is minus half. So there's no negative number, which means there is an error. Where is the error? Where is the error? Our is pi over 3. It's supposed to be minus ln pi over 3. Or on the integral, it's supposed to be negative here, minus. That's where the problem is. Then it's supposed to be minus here. Then it's supposed to be minus. Let me factor out the minus item. Right. So this part is supposed to be minus. And this part is supposed to be minus. So which means if it's minus, then it means this part, it will be simplified. This one was supposed to be plus and minus. And minus was supposed to be plus 1. Then this part, it will remain, it actually remain negative. So it will remain, because this part is plus, so it will be minus, like this. So it will be plus 1 ln 2 minus half. So this part, remove this part. So it will be ln 2 minus half ln 2, which will be simplified to half ln 2. Then done. This will be your final answer shown. Right, next part. So you have to take note of these negative signs. Actually, I'm sure you've seen, you can make an error. Right, question number 7. A curve is such that the gradient at a general point with coordinates xy is proportional to y over root of x plus 1. This one is variation, is proportional to. Gradient is dy dx. Then the curve passes through the points with coordinates 0, 1, 3, e. Then they said, by setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. Our first thing, our gradient, that is dy over dx. They said is proportional to what? To y over root of x plus 1. So this, then the second stage in variation, introduce an equal sign and a constant. So it will be dy over dx is equals to ky over root of x plus 1. This one will be my differential equation. Then now to solve the differential equation, now I've set up an equation. Now I have to solve it. First thing, I separate variables. It will be dy over y is equals to k dx over root of x plus 1. I can say x plus 1 to the power half. Let me just simplify to x plus 1 to the power half. Let me check again. Yes, it's x plus 1 to the power half. Then I have to integrate both sides in this case, right? So integrate both sides. It will be dy over y is equals to k. Then this part, I have to put it as a numerator. Then to the power negative half. Then dx. Then integrate both sides. K is a constant. It's more like a number. That is maybe 2, 1, 3, whatever number. So you don't have to, you just have to ignore that part or maintain that part. This side will be ln y. That's integration of 1 over f of x. 1 over f of x, if you can integrate this part, it will just be ln f of x. Actually, it's 1 over the derivative of f of x, then ln f of x plus a constant. Then it will be ln y in this case. Then derivative of y is 1. Then this part, I maintain my k, then times. Right, integration of this type, I say 1 over minus half plus 1. Then times the derivative of x, which is 1. Then you maintain this part, x plus 1 to the power minus half plus 1. Then plus a constant of integration. Then it will be ln y. Let's simplify this part. Then this will be, all right, let's simplify the denominator first. Minus half plus 1. What is minus half plus 1? It's half. Then half times 1. It's half. Then 1 divided by half is 2. So it will be 2k. Then x plus 1 to the power half. That is minus half plus 1 is half. Then plus c, a constant of integration. Then from this part, I am given that up here, the curve passes through the points with coordinates 0, 1, then 3 and e. So it means this point satisfies this equation, right? Well, this one is the equation of the curve. So I have to substitute to find my constants. Then after that, k and c. Then after that, I will have to make y subject or formula. Because my question is asking me to express y in terms of x. So I put x0, y1. Ln 1 is equals to 2k, then 0 plus 1 to the power half, then plus c. Then I put x3, ye. Ln e, then is equals to 2k, then x3. That will be 3 plus 1 to the power half, then plus c. Then I have to simplify these two items. If you can see, you can get an equation in k and c. Solve them as simultaneous. Then you can find the value of k and c, substitute or replace. Then after that, express y in terms of x. Ln 1 is 0 equals to, then this one, 0 plus 1 is 1. To the power half is 1. So it will be 2k plus c. So from this, you can see, you can say c is equals to minus 2k. Then let me make this one equation 1, so that I can be able to use a substitution method. Ln e to the power n number, e is just e to the power 1, is equals to 1. Then is equals to, then 3 plus 1 is 4, 4 to the power half is 2. Then 2 times 2 is 4k plus c. This will be my equation 2. Then equation, this one was my equation, equation 1, then equation 2. Right, then I can substitute in equation 2 I can say, where they see, I put minus 2k. So I can say 1 is equals to 4k minus 2k. Then to 1 is equals to 2k. Then divide by 2 by 2. You get your k is equals to half. Right. Now, to find our c in this case is equals minus 2 times k, which means 2 times half. It will be minus 1. So my c is equals to negative half, negative 1. Now I can substitute this one is my equation. I can say ln y is equals to, then 2, where there's k is half. So 2 times half, then x plus 1 to the power half, then plus c minus 1. Then my equation, it will be ln y is equals to x plus 1 to the power half, then minus 1. Now from this, you have to make y subject of formula. How? Introduce e both sides. So it will be e to the power ln y is equals to e to the power x plus 1 to the power half, with the same as root of x plus 1, then minus 1. Then e to the power ln n number is called that number. So it will be y is equals to e to the power, I can put root x here, minus plus 1, then minus 1. So this will be my differential equation solved. Right, next question, number 8. The equation of a cave is y is equals to e to the power minus 5x tan squared x, for x lies between minus pi over 2 and pi over 2. Find the x coordinates of the stationary points of the cave. Give your answer correct to 3 decimal places where appropriate. These are 888 marks. Serious one. Wow. So they said find the x coordinate of the stationary point, but the key stationary point gradient, that is dy dx, is equal to 0. That's one item that we know. Give your answer correct to 3 decimal places. Then where appropriate, right? Right. So first thing, you have to differentiate. We are given these 2 items. You can use product u and v. You can say let u is equals to e to the power minus 5x and v is equals to tan squared x. Yes, like this. Right, from integration or differentiation by product, you say dy over dx is equals to v du over dx plus u dv over dx. So that's what you have to use. Is there in a formula appropriate, however? All right, let's find du over dx here. It will be minus 5 e to the power minus 5x. Then dv over dx. It will be, right, arctan is this one. You just take this part. It's here. It's this one. So it will be 1 over 1 plus x squared. That's the derivative. 1 over 1 plus x squared. Actually, this one is not it's arctan. Sorry. This one is arctan, but what we have is tan squared, tan squared, tan squared, tan squared, not arctan. Wow. So this one, you deal with the power first. So power first, then trig, then the derivative of x. So the power, you bring down the power, you subtract 1 to the power. So it will be 2 minus 1. Then trig, derivative of tan x is sec squared x. Then derivative of x is 1, like this. So that's how you deal with this part. Then simplify, it will be 2 tan x, then sec squared x. Like this. So this will be the derivative of tan squared. Take note of that part. Right, then our dy dx will be equals to, then v, what is my v? Is tan squared x times du dx, which is minus 5 e to the power minus 5x. Then plus u, which is e to the power minus 5x, e to the power minus x, then times dv dx, that is 2 tan x sec squared x, like this. Then I can simplify. I will get it's negative 5 e to the power minus 5x, then tan squared x. Then this part plus 2 e to the power minus 5x, then tan x sec squared x. Then this part is the gradient, that will be equal to 0. Then it will be minus 5 e to the power minus 5x. Actually, let me just factor out this part. Let me factor out e to the power and even tan x. E to the power this one, then tan x, like this. Then it will be minus then 5 tan x, then plus 2 sec squared x, then is equals to 0. Well, this is my gradient. Then I can divide both sides by this fellow such that my expression will be reduced to minus 5. Actually, let me take this one. Well, this one, it can also have a solution, right? Because if it's tan, basically you don't have to. It's either e to the power minus 5x then tan. If it's a trig, you don't have to divide. So this part is equal to 0, or minus 5 tan x then plus 2 sec squared x is equal to 0. Then I can get here tan x is equal to 0, or then I can say here sec squared x. Use an identity. You can get a quadratic equation in tan x, right? So sec squared x, basing on our identities, is tan squared x plus 1. Then is equal to sec squared x. Is there in your formula booklet? So the sec squared, I can put 1 plus tan, or tan squared x plus 1. Minus 5 tan x, then plus 2, then 1 plus or tan squared x plus 1, then it's equals 0. Then I can simplify this part. It's minus 5 tan x, then plus 2 tan squared x plus 2 is equal to 0. Then expressed as a quadratic, it will be 2 tan squared x, then minus 5 tan x plus 2 is equal to 0. Right, then this part, you can use your graph on this part. But tan 0, actually, you get 0. And another tan 0, suppose be pi. But our solutions actually is from minus pi over 2 to pi over 2. That's minus 90 to 90. So this one, no solutions on this part, no solution. All the solutions, they're actually out of range. But on this part, let's you can factorize. What are the factors? Two numbers. When you multiply, they give you 2 times 2, which is 4. When you add or subtract, they give you negative 5. What are the numbers? It's minus 4 and minus 1. So it will be 2 tan squared x minus 4 tan x. Then minus tan x plus 2. Then is equals to 0. Like this. Then you factor out 2 tan x, then you get tan x minus 2. This side you factor out minus 1, you get tan x minus 2. Then is equals to 0, like this. Then after that, you can see they are the same inside the brackets. It will be tan x minus 2, then 2 tan x minus 1 is equal to 0. Then for the sake of my space, let me say here, tan x minus 2 is equal to 0, or 2 tan x minus 1 is equal to 0. Right, tan x is equal to 2, or from this one you can get tan x is equal to half. Then find your PV, you can get x is equals to, right, arctan 2 is arctan 2, or x is equals to arctan half, with the same as 0.5. If you want your solutions in radians, please take note of that part. You can find it in degrees, then convert to radians. It works that way. It's very easier. Because radians, sometimes they are a bit complicated to work with. So you can find in degrees, then you can just change to radians. You can just work with radians. So you can say arctan 2 in degrees, let me say, is 63.4. 1 decimal place, then arctan half you get 26.6. So this will be your PV, your primary value or principal value, your PV. Right. Let me use the first part. The solutions for tan. Check. These are all positive, right? I prefer to use the quadrant rule. So tan theta A is 2, is plus 2. Tan theta A is half. So it's plus. So the first part, I can find my solution in the first quadrant, in the third quadrant. Also on this part, the solution, first quadrant and third quadrant. So I can put my angle here is 63.4 degrees. And here, 63.4 degrees. Here, it will be 26.6 degrees. And here, it will be 26.6 degrees. So my solutions are always from the positive x-axis, right? To the line. To the first line, this one is 63.4. But in radians, please, you just divide by 180, right? Divide by 180. It will be. Then this one also is 26.6. So it will be, my x here will be, is 0.46. 464 in radians. Then this part is 1.1 to 3 significant figures. 1.11, right, like this, because 1.107, so it's 1.11 in radians, like this. Done. Because from this one to the second line, that one we don't need it. Why? Because our solutions will be above the limit. So this will be my solutions. So my x is 1.11, or my x is 0.464. Done. There was more space down there. Right. Question number 9. Express f of x in partial fractions. Right. We have a quadratic factor down here. So that will be bx plus c over or on that quadratic factor. So I can say 14 minus 3x plus 2x squared over 2 plus x. Then quadratic factor is 3 plus x squared. Then is equals to a over the linear, which is 2 plus x. Then plus bx plus c over the quadratic, that is 3 plus x squared, like this. Right, then you can get rid of the denominators, right? You multiply everything by the lowest common multiple of the denominator, of the denominators actually, which is 2 plus x bracket 3 plus x squared in another bracket. So this side will be reduced to 14 minus 3x plus 2x squared is equals to, then a will be multiplied by 3 plus x squared. Then my b, x plus c, would be multiplied by 2 plus x, like this. Right, then we have to try and error. Let x be negative 2. If I can say x minus 2, I can eliminate b and c. I can find my a. So I can say when x is equals minus 2, then it will be 14 minus 3, then minus 2. It means wherever there is x, I have to put minus 2 squared, then is equals to a, then 3 plus minus 2 squared, then plus b times minus 2 plus c, then 2 plus minus 2. Then this will be 0. So this whole item will be reduced to 0. So I'll be left with 14. Let me simplify this part. 14 minus 3, where there's x, I put minus 2. Then plus 2, where there's x, I put minus 2. So minus 2 squared. This side will be 28. Is equals to, then this part, 3 minus 2 squared, minus 2 squared is 4. 4 plus 3 is 7. 7a. So from this, I can divide by 7. Then I get my a is equals to 4. Right, to find B and C, I go back to this item. This is the item that I have to use. Then I can eliminate, if I can put x0, can I be able to eliminate this part? X0, I can eliminate a B. Then I have B, I have A and C. Let me put that one. So I can say if x is equal to 0, when x is equal to 0, then 14 minus 3 times 0, then plus 2 times 0 squared, then is equals A, then 3 plus 0 squared, plus, then B times 0, plus C, then times 2 plus 0. Then I'll be left with 14, this left side, is equals, then A, it will be 3A. Then on this side, then B will be cleared, it will be C times 2, it will be 2C, like this. Right, then A is 4. I can put A4 in this case, so it will be 14 is equals to 3 times 4 plus 2C. It will be 14 is equals to 12 plus 2C. Then 14 minus 12 is 2 is equals to 2C. I take 12 to the left side, it will be 14 minus 12 is 2. Then divide by 2, you get your C is equals to 1. Now I'm left to find B. Same item. This is the same thing that I have to use. To find B, I can just put in number that I want. Let me put x is equals to 1. So I can say when x is equals to 1, x is equals to 1, then it will be 14 is 14 minus 3 times 1 plus 2 times 1 squared is equals A, then 3 plus 1 squared, then plus B times 1 plus C, then plus 2 times, where there's x, I'm putting 1. Right, then simplify. Do you have much space? No. Then simplify this part. Let me just simplify. 14 minus 3 times 1, 3, then plus 2. You get 13 is equals to, then A times 4, it will be 4A, because 1 squared is 1, plus 3 is 4. 4 times A is 4. Then plus, then B, C, this side will be reduced to 3. So it will be 3 times B, 3B, then 3 times C, plus 3C. Then where there's B, where there's A, I have to put 4. Because I found my A is 4, then C is 1. C is 1. So where there's A, I put 4. Where there's B, I maintain it. Where there's C, I put 1. Like this. So it will be 13 is equals to 4 by 4, 16. Then plus 3B, 3 times 1 is 3. Right, for the sake of my space, let me just simplify it somewhere here, so that I can use this space to write my final answer. So it will be 13 is equal, 13 minus 16 minus 3 is called 3B. Then 13 minus 3 is 13 minus 3 is minus 3. Minus 3 minus 3 is minus 6. It's called 3B. Then divide by 3 by 3, you get your B is equals to negative 2. Right now, my final item is A, that is 4 over the first one, then plus bx plus c, which is minus 2x plus c is 1 over the quadratic. So what was my quadratic? 2 plus x, 3 plus x squared, then 2 plus x. So this will be the final item. Right, done. Next question. Hence obtain the expansion of f of x in ascending powers of x up to the term in or including x squared. Right, I just have to take these two items, right? So I will just pick this is my answer. So it will be 4, then 2 plus x to the power minus 1. I put them like this. Then plus minus 2x plus 1, or 1 minus 2x. Let me just say 1 minus 2x here. 1 minus 2x. Then times 3 plus x squared to the power minus 1, like this. right? I have to expand first 2 plus x to the power minus 1. Then I'll expand 3 plus x squared to the power minus 1. Right? Expansion of these types is a form of it's 1 plus x to the power n, where n is a fraction or n is a negative number. So it will be 1 plus nx plus n, then n minus 1 x squared over 2 factorial plus n minus 1 n minus 2 x squared x cubed over 3 factorial. So it's there in your formula booklet. The list is here. Is this one. So this is the expression that you have to use. So it's 1 plus x to the power n is this one. Yes, that's the one that's supposed to work in this case. Because our power is actually a negative number. So you can use that. You can use the factorial method. Right. Let's expand this part. But make sure that this part, it must always be 1. If it's not 1, first thing you have to factor out. So it will be 2 to the power minus 1. Factor out 2, divide by 2 inside. So it will be 1 plus x over 2 to the power minus 1. Right. Even this part also, you have to factor out 3. 3 to the power minus 1. Then it will be 1 plus x squared x over 3, x squared over 3, then the power minus 1. Yes, like this. Right, let me deal with the first part. So this one, if I can expand this part, I'll maintain my 2 to the power minus 1, which is 1 over 2. Then it will be 1 plus nx, which is n is the power. That's minus 1 times x, which is x over 2. That's my x. Then plus n minus 1, minus 1, minus 1. Then x squared, that is x over 2 squared, then O over 2 factorial, like this. So they said up to the term in or including x squared. So this will be the term. I just have to end here. Let me see my space. Oh, not much space here. Right, then I have to say half here. Then here it will be 1. Then minus x over 2. Then this part, right, minus 1 is minus 2. Minus 2 times minus 1 is 2. 2 times x squared over 4. It will be 2 times, then this will be x squared over 4, then divided by 2. 2 factorial is 2. Then if I can simplify, it will be half. Then 1 minus x over 2, then plus, then 2 cancel out, it will be x squared over 4. Then if you can remove the bracket, what will you get here? You will get, let me just write it here, right? You will get half minus x over 4, then plus x squared over 8, like this. So that's the expansion. Then on this part, let me take the other item, this one. Let me expand it here. It's 3 to the power minus 1. Let me just put here 1 over 3 right away. So it's 1 over 3. Right, 1 over 3. Then it will be 1 plus, I'm expanding this part, this part, this part, this part. Please take note of that one, this part. So it's 1 plus nx. That's minus 1. X is x squared over 3. That's my x. Then plus n minus 1. N minus 1. Minus 1 minus 1. X squared. That is x squared over 3 over, then squared over 3, 2 factorial. But this part, there's no need. Why? Because x squared squared. That will give you x to the power 4. That will give you x to the power 4. So it means this part, we have to exclude this part, right? Don't ever simplify it. It will just be a waste of time and energy. Then I simplify this part, 1 over 3. Then 1 minus x squared over 3. Right? Then this part, you have to ignore it. Then my final answer, it will be 1 over 3. Then minus x squared over 9. Then I have to multiply these items now. I have to take, where are my answers? I have to take this one. Let me use different ink. I have to take this one. and multiply by up there. It's supposed to multiply 4. I have to take this one, and I have to multiply is this one. I have to multiply 1 minus 2x, right? Take note of that part. Right, let me take the first part. So it will be 4 times then half minus x over 4, then plus x squared over 8. Then plus, was it a plus? Yes, it's plus. Then I take this one. It's 1 minus 2x. Then multiply 1 over 3 minus x squared over 9. Like this, exactly. Right, remove the bracket. It will be 4 times half is 2 minus x. Then plus x squared over 2. Then plus, then this part is 1 times 1/3. 1/3. 1 times minus x over 9. X squared over 9 is x squared over 9. Then minus 2x times, it will be minus 2x over 3. Then plus, then this one will be x cubed actually. Is 2x cubed over 9. For this fellow, I don't need it. I don't need this part because I want up to the term in x squared. Right, so I don't need this one. I have to ignore it. So I have to simplify now. X squared, x squared, x squared. Right, I have my 2 plus 1/3. 2 plus 1/3. 2 plus 1/3. It's supposed to be 2 and a third. 2 plus 1/3. 2 and a third, that is 7 over 3. Right? Then 2x is just x here. It's x minus 2 over 3x. So it's 1 plus 2 over 3. It's 5 over 3. So it's minus 5 over 3x. Then the one with the squared is 1 over 2. 1 over 2, that's half. Then minus 1 over 9 is 7 over 18. 7 over 18, like this. Then x squared. So that's it. Done. Right, next, question number 10. The diagram shows a trapezium ABCD in which AD is equals BC is equals R. AB is 2 times radius. Then the acute angles BAD and ABC are both equal to x radians. Circular arcs of radius R with centers A and B meet at M. Then the midpoint of M, that's the midpoint of AB. So M is the midpoint. Yeah, we have R to A and to B. They said, given that the sum of the areas of the shaded sector is 90% of the area of a trapezium, show that X satisfies the equation, this part. Right, trapezium is half A plus B times the perpendicular height. Half the sum of the two parallel sides, that is A plus B times the perpendicular height, for which A plus B in this case is half DC plus AB, which is 2R, times height. We don't have height. So my height will be from C to the line B, or from D to this line. That will be my height H, right? So to find my height in this case, I can use triangle AD. Then this part, this point, maybe it's O somewhere, ADO. Then I can use a SOHCAHTOA, because this will be 90 degrees. SOHCAHTOA. So using SOHCAHTOA, I can say my height is equal, so the height of the trapezium so it will be, in this case, it's opposite, right? Then we have R, we find in terms of R. Opposite over hypotenuse, that will be sine. So it will be sine theta. Sine theta is opposite, that's H over R. So it will be R sine theta. Sine x actually. This will be x. So it's r sine x. So that's my height. Then I have to find now my DC. DC, I have to find this side AO. Then after finding AO, I multiply by 2 because the same is from this point to this point. Then I subtract from 2r. Then I'll find my DC. Right, find DC. DC is equals to 2 times AO, for which AO is what in this case? AO is adjacent using the same triangle ADO. So it's adjacent, so it will be R cos X, right? Because it's adjacent, it will be cos X is equals to R, it will be AO over R. So it will be R cos X, like this. So 2R cos X, that will be my DC. Then this one, actually, let me subtract it. So it will be, let me just say, minus 2R cos X. So it will be AB, which is 2R minus 2R cos X. All right, more spaced, but let me write it a bit nice one. So I say my DC is equals to 2R minus 2R cos X, right? That's my DC. Done. So I can find the area of my trapezium now. Then for the item, the sum of the areas of the CD sector, right? For a sector, it's half R squared theta. That's the area of a sector, half R squared theta. So now I can apply my item. I can say now, these are 3 marks. I can say now, given that the sum of the areas, which means there are 2 sectors here, times half R squared theta, and the radius is R squared, then theta is X. Then is equals to what? The sum of the areas of the shaded sectors is, so sum, it means 2 times, is equals 90%. That is 0.9 of what? The area of a trapezium. Well, the area of a trapezium is half the sum of the 2 parallel sides, which means DC. DC is this one, that is 2R minus 2R cos theta, cos X. Then plus 2R. That is my AB. Then times height, my height H, that is R sin theta, or R sin X, like this. Done. Right, I just have to simplify and show that it reduces to the one that I have to reduce. Then remove this bracket, it will be R squared X, or X R squared is equals to, then this part is 0.9. Then inside here, I can multiply by 2 everything, such that the item will be reduced to, even 2R plus 2R is what? Is 4R. So half of 4R is 2R. 2R minus R cos theta, then times R sin theta, like this. Then I have to show that it reduces to this item given. In other words, I have to make X subject. So where is my X? This X. So I have to say R squared X is equal to 0.9. Then remove the bracket. It will be, or just remove the bracket, but 0.9 must be inside. So must be outside. So let's maintain our 0.9 outside, right? Then we can, it will be 2R squared sin theta. But sin theta must also be outside, so we don't have to put it inside. So let's just put R squared inside. R inside, then minus, then R squared cos theta, then sin theta, go sin theta, Why am I putting theta? Supposed to be X. Like this. Then you factor out R squared here. It will be R squared X is equal to 0.9 R squared, then 2 minus cos X, then sin X. Right, like this. Then you divide everything by R squared. By R squared, both sides, you get X is equal to 0.9, then 2 minus cos X, then times sin X. Then we can say done. So this is what you're supposed to do. right? Shown. Then next, verify by calculation that x lies between 0.5 and 0.7. By calculation that x lies between 0.5 and 0.7. Right, so you just have to use this same item. You take everything to one side. I can prefer to the left side. It will be x minus, then 0.9, then 2 minus cos x times sin x. Then I can say, let this item be equal to f of x. F of x is called this item. Then if there's a root, I have to put f of 0.5. I have to put f of 0.7. Then there must be a sign change. So let me put f of 0.5 first. Is equals to, then where there's x, I put 0.5. And make sure your calculator must be in radian mode. Minus cos 0.5. Right, what do I get here? Then I put f of 0.7. It will be 0.7 minus, then 0.9, 2 minus cos 0.7. Then what do I get here? If there's a sign change, then you can deduce that or conclude that there's a root. Right, calculator in radians. 0.5 minus 0.9, then 2 minus cos 0.5. Then there's one item missing, is sine 0.5 outside. You get 0.015696. So there must be sine here, 0.5, and there must be sine here, 0.7. Then if I can put 0.7, it will be 0.7 minus 0.9, then 2 minus cos 0.7, then times sine 0.7. You get negative 0.01614. Right? These numbers actually, they are not a problem. What you just want are the signs. So you can say this number and this number. The sign is plus here and the sign is minus. Therefore, there is a root. Why? There is a root because there is a sign change. That's what you have to write. There is a root since there is a sign change. Done. Then part C, show that if a sequence of values in the interval 0x0 to pi over 2 are given by a iterative formula, this one, converges, then it converges to the root of the equation part A. So this part, what you have to do, you have to show that this equation actually reduces to this part, right? Just like that. It reduces to that part. So you have to remove n plus 1 and n and just maintain your x or put your x. So it will be x is equals arc cos. Then 2 minus x over 0.9 sine x. Then after that, you can arc cos, you put cos the other side, it will be cos theta or cos x is equals to 2 minus x over 0.9 sine x. Then let's get rid of our denominators, multiply everything by 0.9, right? Or let's just take this one, x, because it's supposed to reduce to that item there. Then we have to make this x subject here. So it will be x over, then 0.9 sine x, then is equals to 2 minus cos x. Right, it's working. Then let's make it this x subject. It will be x is equals to, then multiply everything by 0.9 sine x. It will be 0.9 sine x, then 2 minus cos x. Then we can just say x is equals to 0.9, then 2 minus cos x, then sine x. Just like that. Then shown. 2 marks, 3 marks. Right, part D, use this iterative formula to determine x correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Right now, to determine the root, use this equation, right? So x0 must be, we have this part, that there is a root between 0.5 and 0.7. So you say x0 is equal to these two items, 0.5 plus 0.7 over 2. What do we get? Is 0.6. That will be your x0. Then x1 is equals to, right, use x0, but you must use this equation. So it's arc cos of 2 minus is it 2 minus, yes, xn, that is 0.6 over 0.9 sine xn, 0.9 sine 0.6, like this. So this will be your x1. So if you can punch in your calculator, what will you get? It will be arc cos of, you press arc cos, make sure your calculator is writing mode. So 2 minus, you put your over 0.6 divided by 0.9 sine 0.6. Close your bracket. So it's 0.610 to 4 decimal places. 0.610, then 6 to 4 decimal places. Then x2 is equals to, so it will be arc cos of, where there is a x, now we are putting x1. So it will be 2 minus 0.6106 over 0.9 sine 0.6106. Please take note of that part. Then in your calculator, you can just do it in the easy way. Where there is 0.6, you can just put answer. Where there is up there, you can just put even answer. Then it will just make more. It will just be perfect. So it's 0.6151. They say to 2 decimal places. Let's check here. 0.612. So not yet. Let me move on to x3. It's arc cos of, then to be 2 minus 0.6151 over 0.9 sine 0.6151. Then what will be the answer here? It's 0.6170. Now if you can round this one, you get 0.62. Round this one, you get 0.62. So that's the root. So x root is 0.62 to 2 decimal places. Done. Right, next question. Question number 11. With respect to the origin O, the points A and B have position vectors given by OA is equal to that one and OB is equal to that one. Show that OA is equal to OB and use a scalar product to calculate angle AOB in degrees. Show that OA is equal to OB. These are the length. So just have to use magnitude, right? So use magnitude of OA must be equal to magnitude of OB. The length of line OA, OB. What is OA in this case? OA is this one. Is true. So your vector is supposed to be I, J, and K. It's supposed to be in this form always. So I, there is 2, then J is minus 1, then K is 0. That's OA. Then OB is equals to, then it will be this one, there is no I, which means 0, then J is 1, then K is minus 2. So to find the modulus or magnitude of OA, it will be equals to, then OB, it will be equals to, right, it says square root of 2 squared plus minus 1 squared plus 0 squared. OB is square root of 0 squared plus 1 squared plus negative 2 squared. Right, this part simplify, what do you get? You get root 5. Then here, this side simplify, you also get root 5. So you can say that, so you can see, so root 5 is equals root 5. Therefore, OA is equals OB. Then now they said, and find and use the scalar product to calculate the angle AOB. AOB is like this. So it will be this angle theta. So use the dot product OA, then OB. OA and OB. So you say cos theta is equals to OA dot OB over the modulus of OA dot the modulus of OB, like this. So it will be cos theta is equals to, actually our theta is AOB. Let's just learn to use AOB. It's AOB, AOB, AOB. Is AOB, then is equals to, right, OA dot OB. In this case, we can say, what is my OA? Is 2 minus 1, 0. Dot, what is my OB? Is 0, 1 minus 2. 0, 1 minus 2 over the modulus. I have already found them. So it will be root of 5 times root of 5, which will be simplified to 5. So it will be cos AOB is equals to, right, modulus, dot product is 2 times 0, which is 0, plus minus 1 times 1 minus 1, plus 0 times minus 2 is 0, over root 5 times root 5 is 5. So it will be cos AOB then is equals to negative 1 over 5, like this. Well, then simplify, what did they say? AOB in degrees, right? Not in radians. Please take note of that part. It's not in radians, but it's in degrees. Then you say cos, which means AOB, our angle, is at cos of negative 1 over 5. Right? This one is supposed to be obtuse. Cos obtuse, cos of a negative number, that's actually obtuse. So a calculator, you have to make sure it's in degrees mode. Convert to degrees, then add cos. Press second function, then minus 1 over 5. Minus 1 divided by 5. Then close your bracket. You get 101.5. Degrees. Let's check the degree of accuracy. Not specified. 1 decimal place if it's an angle in degrees. Right, next. Question number, part B. Right, so on the last one. Part B. The midpoint of AB is M. The point P on the line through O and M is such that PA is S to OA is equals to root 7 S to 1. Find the possible position vectors of P. Right, these are 6 marks. What you have to do, you have to be a bit more, Right, take this one. PA S to OA is the same as PA over OA is equals to root 7 over 1. Which means our PA is equals to root 7 of OA. Like this. So this is the item that you have to work with, right? Especially on vectors. Right, let's see. Let me draw now. To simplify my things. Let me use this part. They say the midpoint of AB is M. Let me put my O. So my O is somewhere here. That's my O. Then OA. OB. Put my B somewhere here. Then my A somewhere here. So vectors, I just have to sketch your items. Otherwise, it's a problem. So OA, then OB. What is my OA in this case? My OA, I have found it. It's 2 minus 1, 0. 2 minus 1, 0. Then my OB, what is my OB? It's 0, 1 minus 2. 0, 1 minus 2, that's my OB. 0, 1 and minus 2. Like this. Yes. Then they said here, the midpoint of AB is M. Midpoint of AB, this one, is supposed to be M here. Then they said, the point P on line, the point P on line through O to M. Right, my line through O to M is this one. This is my line. So P lies on this line. It's such that PA, I can put my P on this point. P. Then PA is this part. That's my PA, right? Is that PA S to OA is this one, root 7 over 1. Right, so this is my item. It's coming out. I have my OM. Right, so they said the point P on the line through OM. which means you have to find the vector equation of the line OM. So vector equation is R is equals to OM So in this case, the OM is the direction of vector. So actually this one is O, which is 0, 0, 0. Is point O, then plus lambda, then I can put OM, that direction of vector. So O is 0, 0, 0. So this one will be R is equals to 0, 0, 0, then plus lambda, then OM, actually, since we have M is the midpoint, so it find AM. But first, you have to find AB. Wow. So AB is equals to AO, or you can say B minus A. That is OB minus OA. And this thing must appear even down here. Down here, actually. That was the first thing that you have to do, actually. So you say AB is equals to OB minus OA. That's AB, which is OB is 0, 1 minus 2. Minus OA, which is 2 minus 1, 0. So this will give you minus 2, 2, minus 2. So it's minus 2, 2 minus 2. Then AM, because we want to find AM here in this case, so that you can be able to find our vector OM. Because OM in this case, OM is equals to, you say OA plus AM. That's OM, right? Like this. Then AM is half of AB. So half of minus 2, 2, minus 2, which is equals to minus 1, 1, minus 1. So it's minus 1. So this part AM, minus 1, 1, and minus 1. Like this. Right? Then you have to find our OM now. So OM is equals to OA plus AM. OA plus AM, right? What is my OA? OA is 2 minus 1, 0. Plus AM, that's minus 1, 1, minus 1. If you can simplify this, you get 1, 0, minus 1. That's OM. So this is the item that you have to put now at this point. Yeah? So it will be 1, 0, minus 1. And the vector equation of our line through M, from O to M, it will be R is equals to, then if you can combine the items, so this on the vector equation of the line. So you can just say R is equals to lambda, then 1, 0, minus 1. Because 0, 0, 0 is the origin. Right, take note of that part. Right now, we're being told that P lies on the line. Want to find the position vector of P. The position vector of any point on the line, you just combine your points on the line. So it will be 0 plus, so it will be 0 plus lambda times 1, lambda. Then 0 plus lambda times 0. Then 0 plus lambda times minus 1, minus lambda. Like this. And it will be lambda 0 minus lambda. So this one represents the position vector of any point on the line. Position vector of any point on the line. In this case, it will represent position vector OP. That's the position vector of P, right? Aha. Right. Now I have to find, I'm given that PA is to or over OA, or PA is equals to root 3 of OA. In this case, I have to use my magnitudes. Please take note. I have to use my magnitude here in this case, so that I can be able to find lambda, the position vector of P. Then in that case, it will be able to make sense. If I can find my lambda, then I will have the position vector of P. Because this one represents position vector of P, that's OP. Right? So I have to find the values of lambda. Then I can substitute. I have my values. Done. Just like that. Right? Then I have to find my position vector. So I have my OP. Then my OP, I have PA here. Then I have my OA. OA is this one. Then I can find my PA here. Because PA is the one that whose relationship is explained in this case. So let me find my PA. AP. So PA, actually PA is PO plus OA. OA minus P. I can find my PA. PA is OA minus OP, done. So what is my OA here? OA is minus 2. It's 2 minus 1, 0. Then minus OP is lambda, 0 minus lambda. If you can simplify these two items, what do we get? 2 minus lambda. Then this part minus 1. This part lambda. So this one is actually PA, right? Right. Then PA is this one. But I'm being told here, PA is equals to root 7 of OA. So PA, I can find this one. It will be square root of, I find the modulus functions. It will be square root of, then it will be 2 minus lambda squared plus minus 1 squared plus lambda squared. Like this. Then is equals to root 7 of what? Of OA. What is my OA here? OA is minus 2. Is 2 minus 1, 0. 2 squared minus 1 squared, 0 squared. Then I simplify, I find my lambda. I will substitute in OP. So it will be here. I can just remove the square root, right? Square everything. It will be 2 minus lambda squared plus 1 plus lambda squared is equals to 7 here. Then times 2 squared, it's actually 5. Right? Because this will be root of 5. It's actually 5. So it will be 35 this side. So it will be, then you remove this bracket, you expand. Expand, remove the bracket. 2 plus lambda. Then 2 minus lambda, 2 minus lambda. It's not plus, it's not plus, it's minus. 2 minus lambda, then 2 minus lambda, another bracket, then plus 1 plus lambda squared, then it equals 35. Then expand this one, find lambda. It will be 2 times 2 is 4. 2 times minus lambda is 2 lambda, then minus 2 lambda, then plus lambda squared, then plus 1 plus lambda squared is equal to 35. Then after that, minus 2 lambda is actually minus 4 lambda. So it's 4 minus 4 lambda, then plus lambda squared is 2 lambda squared, then plus 1 is equal to 35. Then simplify this part. It will be 4 plus 1, 5. Let me start with 2 lambda squared, then minus 4 lambda, then 4 plus 1, 5. From 35, it will be minus 30. 0. Then divide everything by 2. It will be lambda squared minus 2 lambda minus 15 is equal to 0. Then you can factorize here. Lambda, can it be factorized? Let me check. It's equal to 0. Then two numbers, when you multiply, they give you 15. 5 and 3. So it's minus 5 here. And plus 3. Like this. So lambda minus 5 is equal to 0. Or lambda plus 3 is equal to 0. So it will be lambda is equal to 5. Or lambda is equal to negative 3. Right? Percent vector OP now, I have been given as, let me check up here, is this one. Lambda 0 minus lambda. Lambda 0 minus lambda. Lambda 0 minus lambda. So which means this one, when lambda is equal to 5, then OP will be equal to 5, 0 minus lambda. When lambda is negative 3, then OP is equals to, this one will be minus 5 actually. It will be minus 3, 0, 3. So these are the two possible vector, actually percent vectors of P. Right then, after watching this video, please like, share, and subscribe. Say Mangeya, the Maths Eagle, signing out. Signature. Thank you.